to the cloud. Okay, so so every CW script compilation requires you to build a CW script project. It's basically, just package.json or just like a solution file in C#. Basically, yeah, it kind of organizes all the contracts you want to build together. So when you do CSWC new, you need to basically define the name of the project that you're building, and project contains multiple contracts. So basically we have like a config in the Tomo file, and the smart contract source code goes in the SRC, and then we run the build. It builds to an output. So I'm actually in the process of adding the project manager. So it doesn't work as of right now. But basically that's the workflow for a developer on the other end. So they create their contracts, put them in the source file, source folder, and then they run SWC build, which, goes through all the contracts and then compiles them into Rust output, right? And also the documentation as well. Right. So if I go to the examples and kind of show you what a contract kind of looks like. So this is what a contract file looks like. It's, like I said, I wouldn't be going over too much of the language features in this talk. But yeah, so we can see that it has like a contract source code and the contract project configuration. I can define, various things, metadata about the project, and then, change some settings on the compiler, right? So, and then in addition to that, we're making it extensible such that people can install third-party tools that interact with the compiler, and the compiler will detect them on the user's environment. This is a tool called Generate Docs. It will generate docs, and then there's like custom options for each tool. Here we define the format as HTML. So each of these tools will have their own sort of
thingy.
Right. And then here's one is called Gen Client Lib, and then these like kind of create client libraries that we can use to interact with the contract.
Okay.
So those are additional tools, but those are separate from the compiler. Okay. So, any questions so far?
Yeah. So the compiler is also a build tool, basically.
It is a tool, but it is the central tool that organizes all of the other tools. So it's like, how Git, you can install like git dash some other tool name. You can. Yeah. So we're going to follow the same pattern here, where you can install compiler tools by npm g install these CWC dash, right? Tool dash. All right. So so basically the compiler is like a project manager and a compiler in one. The compiler exposes an API, and we use this API to basically introduce some language services. So let me go into the CW script VS Code extension, which is the other. Okay, so this is the other thing that I plan to ship version 1 of. Basically, it's going to, let's see. So go to PM link. Okay, and then I'm going to basically, this is the VS Code extension, and it includes syntax highlighting and some language features exposed by language server. So the structure of this is so this is composed of, shit, what the fuck? Sorry. CD, script, VS Code extension right here. Okay. Okay. Let me go into this one. All right. This one is jank. Okay. So there are two parts to the VS Code extension. There's a client part, which hooks onto the VS Code thing, right? So it's a standard. This is basically very standard, and it activates the VS Code extension, instantiates the server. Also written in TypeScript, so you can see that we create the module called server out server.js, even though everything is created in TypeScript. So we have these TypeScript outputs. So that creates a server and then starts listening to it. So you don't need to edit this. We don't need to edit this anymore because this is just the standard like loading and extension. But so the main things happen here in the server. So it's quite simple. So I've kind of reduced it to this. So this is what it looks like. Okay, so how it works, so each of these, so the syntax highlighting is provided by like some TextMate grammar written in JSON. So I'm having my compiler intern do all of these regexes.
Oh, joy.
But, yes. I think we're going to simplify it a lot, but yeah, he's going to have a lot of fun doing those. And the main language services come from these. So I basically, register these services individually. So each service is this general structure doesn't need to be changed. All you need to do when you need to change the logic of a service is go into each service file and then extend that. Hold on. Sorry. I forgot I needed to, I changed this a little bit. Hold on. Export. Wait. Static analysis. Static analysis / source validation. Index. Okay. Yeah, so let me just export. Okay, and let me. Okay.
What's T1?
T1, turn 1.
Oh, that's the okay, fine.
That's just my project folder. Yep.
Yes, strange way of showing the folder.
Yep. Okay. So, all right. Okay. So some problems. Okay. So each service kind of has, so the service is basically extends this thing. The main thing that each one does is service name, register service, and then capabilities. Right. So then each service register defines its. Yeah, basically the logic comes in here where it's registered and hooked onto the language server upon registration. So what this one does is, it gets the connection and the documents from the server.
Yeah, I sort of understand this.
Yeah. So, basically it runs this logic, which passes through the AST and then gathers the static analysis things. So how we debug this is we have like a launch JSON, and we have a custom one called extension host, which allows us to debug in isolation the VS Code extension. And then so when we run debug, when I debug it, right, it will launch this thing. And then I have a test workspace where I can test all these things. As you can see, like here's the document symbol service where you can where that
That's
is
the AST,
installed.
yeah.
Right. No, that's not the AST, but like the symbols that are gathered from
Symbols.
the AST.
Oh yeah,
Right.
yeah.
Yeah. So all of the tools
Top level,
work on
yeah.
the AST, right? So
Yeah.
these are exposed through various services. So this one in
Yeah, yeah.
particular, this one is document symbol, right? So
Right.
each of them are just a language server events, and then they follow the language server sort of syntax. Let's see. So
Okay.
so this one in particular, we have the symbol. So then when we try to search for the symbol, it can go to the right symbol. There's another one called like validation. So I have I defined the state here, but let's say I try to do something here. So like here, this is a diagnostic, and then these are just reported from the compiler. So there's something wrong here because owners is not defined in a contract. So we just register each of the language services independently, and then work like that.
Yep. Really
Okay.
cool.
Cool.
Love it.
So yeah, so like normally if you look at the language server examples, they won't look like this. I just made it look like this, so then it's cleaner for us to add these services. Usually
Yeah,
it's
it's very
just like in
followable.
one file. So we this is something we're going to be working on as well. So there's a bunch of services that I have yet to add but want to add, like code completion, code lens, right? Like some actionable item on top of the code thingy. So there's various ones, and those can be found like on the
maybe.
refactoring, like find symbol, find type. But like all of those are listed on the VS Code programmatic features. We can add them incrementally and make our language very nice to use with the tooling. And in VS Code is a great thing to build on top of.
Yep.
Also, the language server is not necessarily specific to VS Code. So we can find integrations for Vim, Emacs, JetBrains.
Nice.
Yeah. So we'll be working on those extensions as well. But, low priority, I think the VS Code extension is probably number one. Okay, so that's the VS Code extension. The compiler-wise, I want to give you like a sort of compiler tutorial. Like we're going to just implement a small language from scratch to kind of get the entire workflow, and then translate our knowledge to the CWSC compiler structure. And then that should kind of like it's a trivial example, but we need to kind of get like how from a trivial example we like drive that. So I want to give you like a tutorial on how to use Antler and how we use Antler. I think that'd be helpful, even though it's very simple. So there's various components on this, but then I'll go through them later. So from the high level overview, we have.
I did build a small compiler in the past, but not with Antler.
Cool. So it's actually not right. It's not really a compiler, it's a transpiler. So I think that one of the main thing here is the main contribution is we have
I'm not quite sure what the difference is.
just the when you look at compiler books, there's a huge section dedicated to code generation, and usually it treats code generation in a low level thing. So with LLVM or just like what they call like 3 address form. Here we just need to transform it into Rust, right? So Rust has an interesting like sort of borrowing mechanism and memory model. So we actually create a subset of it, and then everything, we call it the CW script abstract machine, and then everything in CW script will compile into the abstract machine instructions, and those are guaranteed to be coherent with the CW script. I mean, with the Rust sort of memory ownership model. Yeah.
Okay.
So something I'm working on is the what I call the CRI or CRI, the CW script to Rust interface. It's like the JNI of CW script. Like how do we introduce additional functionality from Rust and how to expose Rust objects such that they can be used within CW script. So I'm currently working on that. We also have a separate type system from Rust. So we don't necessarily use Rust directly, but and it's not a direct transpilation. We do have an intermediate step where those have analogs in Rust following the CRI. Yeah. So I mean, like the code is very organized in logical things. I think that the other thing it might be so on a high level, you know, we generate the AST, right? And then we basically walk the parse tree and generate various AST nodes based on this. Mm-hmm. And you know, all the nodes are defined. And sorry, heartburn. All the nodes are defined, and we have we have on the root node. I mean, the root base class. We have like a sort of it's in the. We have like a couple methods that are helpful, like walking the ancestors. Tree traversal algorithms, you know, that are helpful for analyzing or walking the AST. I think that the thing is, like, you know, CodeGen is where it all comes together.
Oh, right, AST to Rust. There you go.
Right. So one of the core things we are spending time working on is building a model of Rust inside TypeScript. So it's in the Rust Rust directory. So I have a minimum model of Rust. You know, every sort of like, you know, like a and in these transform to strings. But they also have so each expression I can create new Rust expressions, and it has an understanding of the Rust types. So then, like, each expression has like a Rust type as well, and those basically implement, you know, to Rust string, which yeah. So we basically construct from the AST to Rust is basically creating, you know, for example, a let variable statement that converts into. Oh, sorry. This is the AST to Rust. Basically, we have like temporary variable generators, and then we have these like translation methods, which, you know, kind of translate them. Right.
Okay.
Like, yeah, arithmetic binary operation. Right.
Yeah.
Cool. Yep.
Right. So you walk the tree, and then you have. It's a sort of a visitor pattern, more or less.
Right, exactly. Yeah. So it's a visitor pattern on the tree. I thinking of abstracting it even further to a intermediate part, just because we need to do some additional processing, and we can't go immediately from the EST to Rust because there's a bit more complications I need to add. Yeah, so then this might change in the next coming days.
Yeah, I wouldn't make it Rust specific if I.
Yeah, right.
I mean, not because we need to do anything else, but basically it should be AST specific, right? No,
right. It should
AST
be
merge.
So we should have like a intermediate representation that can be generated from other processes other than CW script. If we want to support new language front ends, so they just need to, and then we also need to do some. So there's also some like checking, so checking can be done on the AST, but we kind of need to generate a more abstract model of some of the things, just so that they are consistent with the CW script itself, because the AST itself is just, you know, it's just a representation of the syntax. What we really need after that is just to generate the model that
the features,
the syntax. Right. So we kind of have to have another layer after that, but from that layer we can generate directly Rust, I think.
Right.
Okay.
I was wondering. So Rust is then compiled to WASM, right?
Yes, but we don't handle that because that is a whole
Because
other
it's
can
done,
of worms.
done in Rust.
Right. It's done
Have
using
you ever
Rust.
have you ever considered outputting WASM directly?
Yes, I have, but I've also I've looked at like what it would take, and it's in my opinion just not worth the hassle, and we get a lot more benefits by transpiling to Rust in before. Because number one, there's a lot of the optimizations that Rust makes, and the LLVM is kind of hairy, and then it's not well documented how Rust itself translates to WASM.
Right.
I think it's on the roadmap but it's not a high priority just because it's not worth the complexity right now, because you'd have to because a lot of the CosmWasm libraries are only written in Rust, and basically we'd have to import all of them.
The library. Yeah.
Right. And then there's actually not a standard ABI for Rust such that you can combine WASM files together. So I think that right now we're suffice with Rust transpilation.
Simplest thing that works.
Right.
The other thing I was thinking is
Yeah.
Roslyn. That's another possibility. I think Roslyn can output WASM.
Yeah. But the thing is, like, it has to work with the Rust libraries of the CosmWasm thing, because it actually
He has to work with the compiled version of those, right?
No. So actually, there's not a way to combine those Rust made like WASM. Like you can combine WASM files, but there's not a standard way from Rust compiled WASM to that, because it actually is a little different. So I've looked into it, and I've just figured like it's actually we also have to thinking about like the auditors when they go and audit the Rust code. Like there's a separate audit process for the compiler, and then there's the audit process for the contract, right? So then right now, if they were just to audit the contract, I think that we need to kind of make it compatible with that system as well.
Yeah.
And
okay.
plus we need to introduce like Rust bindings for people who want to extend their contracts with Rust. So I think that Rust transpilation is the best middle ground.
Yep, at this point for sure.
Yeah. Okay. So cool. So that's pretty much all of most of the compiler. I think we can get into that in a later session. Maybe we can go in and talk about the. Maybe we can get you set up with writing a smart contract on getting your Terra development environment set up. Maybe. Mm-hmm. So maybe we can share your screen.
Sure. You want to stop recording?
Yeah, and then restart recording.